Hello Year 11 and welcome to our second lesson on chromatography. So in our first lesson we learned what chromatography is and we learned how to set up the process of chromatography. So just to recall, chromatography can be used to separate mixtures made up of liquids of different colours. And we are going to look at today at an example of this where we've used paper chromatography to separate different dyes in an ink. So here is an example of how we'd set up this method. So as you remember, we first of all start with our baseline, which we must draw in pencil. The reason we draw it in pencil is because pencil is insoluble, meaning it will not dissolve and therefore it will not move up the paper with the water or the solvent. We're going to use the key term. So all I have done is drawn the baseline or the origin in pencil. I marked on 3 crosses and then I have put my different inks on there, and you can see I've got 3 different inks. You then place, it should be filter paper, but I've used kitchen roll. You then place this into the solvent, making sure that the solvent doesn't pass the line and that these inks are not sitting in the solvent, otherwise they will also just dissolve and wash off. So here you can see an experiment that we set out earlier. So if we pull this out and have a look at it, we can see that out of the 3 inks, 2 of them were soluble. You can see they have moved up the paper. 1 was insoluble as it's not moved from the origin or the baseline. We can see that the first one here was made up of, at the moment we can see 2 different colours, and the second one we can also see the 2 different colours. Hopefully you can see that it's separated into. So what we're going to look at today is how we actually use this information, this chromatogram, to calculate something called an RF value, which allows us to identify these inks. So the first thing we are going to do is we are going to draw a line to where the solvent reached, and it reached to here, and this is called our solvent front. So the water actually went up to here. Okay, now we'll move that away and we'll look at this example here. So we are going to calculate the RF value of substance A. And to calculate the RF value is just the distance travelled by the substance. And what's really important is that you remember that it is from the centre of the substance. So I'm going to draw a line at the centre of the dot. And I strongly suggest in your exam, if you're asked to calculate the RF value, you do this too. You identify where the centre of that dot is. You then have to divide that value by the distance travelled by the solvent, which is why I drew the line up to where the water went up to on this one. Okay? So to work this out, we're going to draw the distance travelled by the substance divided by the distance travelled by the solvent. Remember, the solvent is just another term to describe the liquid in which the substances have dissolved. So to do that, we are going to measure the distance travelled by the substance. So using a ruler, placing it at the centre of the dot and going down, and I can see that this is 4.3 centimetres, or I might have measured it in millimetres. Now it doesn't matter if you measure it in centimetres or millimetres, as long as you measure both of these in the same unit. So that is 4.3. So I'm going to write here 4.3. I'm now going to measure the distance moved by the solvent, so the distance from between the origin or the baseline to the solvent front. So I'm going to measure it again, as I did the one before, in centimetres. I'm going to do this one in centimetres, and I can see that it is 7.4. So to calculate my RF value, it is just going to be 4.3 divided by 7.4, which gives me an RF value of 0.58. And that is all you have to do in your exam. Okay, you just need to measure the distance travelled from the origin to the centre of the spot they've asked you to calculate the RF value for. Then measure the distance travelled from the origin to the solvent, so the distance, in this case the water moved up the paper. Making sure that if you've measured this distance in centimetres, you measure this distance in centimetres. And then you just divide the distance travelled by the substance divided by the distance travelled by the solvent. Now, if you ever get a value greater than 1 or 1 or above, you have calculated this wrong. Okay, it has to be less than 1. Thank you for watching. I'll see you soon.